Okay, these are the Section 10.5 notes, tangents to circles. So we begin with a lot of just vocabulary on circles. So first off, what is a circle? It's a collection of points that are all equidistant from a certain point. Okay, and that certain point would be the center. So in this circle here, we've got the center, which is just that dot there, and center is usually just labeled with a letter. So let's say we label it P. That would be circle P. Next is a radius. Radius comes from the center and hits the outside at any point. Okay, all the radiuses are the same. Diameter goes all the way through, but it has to cross through the center. So it's different than a chord, which is our next word. The chord crosses through the circle, but does not cross through the center. A secant is one that passes all the way through the circle, not just stopping at the endpoints like a diameter or chord would do. And a tangent line intersects the circle at one point and one point only. That's what makes it tangent. Okay, so a point of tangency would be that point in which that occurs. So looking at this example here, that would be considered our point of tangency. That's where the tangent line touches the circle. So here in example 1, we just have to come up with the best word for each of these. So looking at the first one, we've got HG. So HG is this right here. Let's see, let's get out a highlighter for all this. So we've got HG, which is right there. And it looks like it touches it at just one spot on the circle, so we'll say that that is a tangent. And next we have EF. So EF is here, and EF crosses all the way through, or not all the way through, I'm sorry, touches the two endpoints but doesn't go through the center of the circle, so that would be a chord. Next we have DB. DB is right here. So this one goes and touches both ends of the circle and passes through the center. So that would make it the diameter. Next we have EF. Okay, and we've already done EF. So EF is still a chord. Okay, C is the right there. That's the center. CB. CB is, where's CB? Right here. So CB comes from the center and goes to the outside. That would make it the radius. FG. FG is a line. It goes all the way through the circle, so we'll call that a secant. Next we have A. A is right here. You'll notice that it has just a single point with a line touching the circle, so that is a point of tangency. And last we have DC. DC looks to be the same as CB, just going the other direction, so that is a radius. So those are all your vocabulary terms and how they're used. Okay. So we have some properties that we want to use and know. So first off, a line is tangent to a circle if it is touching it at just one point, and that would make it perpendicular with the radius if it is indeed tangent. And then if you have two lines coming from a single point tangent to a circle, then they would be congruent. So looking at these two examples, if I was to draw a line from here, that would be the radius, That would have to be perpendicular for it to be considered tangent. And here, if I have this line and this line, okay, so stopping right here at C and B, they would have to be congruent if they are both indeed tangent. So we're going to see this in practice. So first off, example 2, we're determining if it is in fact tangent. That would mean we'd have to have a right angle here. And for that to be a right angle, we would have to use Pythagorean's theorem and have that hold true. So we would have to know that 61 squared equals 60 squared plus 11 squared. So we need to know what those particular things are. So you'd have a calculator for this that you need to put it in. So 61 times 61 gives us 3,721. 60 squared gives us 3,600, and 11 squared gives us 121. So that would total up to 1273, which is equal to 3721. So yes, EF is tangent. Is a tangent. All right, and example 3 shows us the other thing. So we have lines stemming from a point. It's telling us that they are points of tangency in the directions. So we need to find the value of x in each case. So the first one we have CM is congruent to CK, so we'd set them equal to each other. X plus 3 equals 7. And solve. X equals 4. Same thing for part B. We'd set them equal to each other. And here we'd want to subtract 4x. And then we'll add 8 because it says subtract, so we do the opposite. 15 equals 3x divided by 3. 15 divided by 3 is 5, so we'll put it right here. X equals 5. And here for part C, we'll start up here because we might need a little more room. So 3x squared minus 10 equals 17. So 3x squared equals, we add 10 to both sides, 27. Divided by 3, x squared equals 9. In order to undo a square, we just take the square root. Now generally we get plus or minus 9 or plus or minus 3 for our x values. Since I don't see anything, we're going to go ahead and leave it as that. So plus or minus 3. Both numbers can be plugged in because negative 3 times negative 3 is the same as 3 times 3. Okay, last two examples here. Example 4, saying to find x, but there is no x there, so let's put an x in. We'll say that's x. Okay, so if F, C, and EC are both coming from C, then these two lines have to be the same, so that would have to equal 8. Over here, we're missing AD, but AF comes from the same point. So that would have to be 12 as well to match up here. And here we've got BD and BE both coming from B. So that would have to be 6. So we'd have the perimeter of 12 plus 6 plus 6 plus 8 plus 8 plus 12. We add all of those up, we'll get our total. So we've got, that would be 20, that would be 18, that would be 14, those would go to 32, add the 20, 52 for that one. Okay, and then we have this one. This one does have an actual x and y, so we can solve for those and then find the perimeter. So once again, here we've got these two coming from the same point. So if this is already 4, y would have to equal 4. Over here we've got these two being the same, w into this point and here, so 3x equals 6 divided by 3, x equals 2. So now we can plug that in. We've got 6 here, that's still 4, that's 3, this is 7, this is 7, and over here we also need a 3. So essentially 2 of each of them. So we'd have 2 7s, 2 3s, 2 4s, and 2 6s. And then we can just add them together. 7 and 3 gives us 10. So we've got 2 of those, so that gives us 20. And 4 and 6 give us 10. We got 2 of those, that gives us 20. So our overall perimeter would have to be 40. And that concludes the 10-5 tangent circle notes.